Okay, what we're gonna do in this final problem of our online lesson 2, labor supply, is we're gonna decompose substitution effects from income effects. In the previous problem, we had an income effect because we had a parallel shift in the budget line. Here, we're gonna have a rotation of the budget line. And when you have a rotation of the budget line, because of a change in the wage or a change in the net wage, net of some, tax, there's an income effect and then there's a substitution effect, right? Because one, leisure is a good, right? Leisure is a good that costs W, right? W is the wage. And when the price of leisure goes down, the quantity demanded for leisure goes up, right? So we're essentially consuming more of a good named leisure. If the wage goes up, the price of if the price goes up on our labor, if our wage goes up, then the price of our leisure goes up. We're going to consume less leisure, right? But when our wage goes up, we feel wealthier. So when we feel wealthier, there's this positive income effect, but there's also the substitution effect, right? So we're going to explore and decompose the income and the substitution effects. So in this problem here, our time constraint is 80 hours. 80 hours can be used for leisure or labor. Our wage is $9.80. Right? Our wage is $9.80. This is our indifference curve, right? Anywhere on this curve, the utility is $3.98. So the consumer is equally happy with this point as she is with this point, as she is with that point, right? And then this is our budget constraint. That's our budget constraint, right? If she works 80 hours a week, she has zero leisure and her earnings are 784, right? If she has 80 hours of leisure a week, she works 0 hours a week, she has zero consumption. Because in this model, the allowance is zero, right? There is no weekly allowance. So if she does not work, she has no money for consumer goods, right? And then our optimal point is where this indifference curve, where an indifference curve is just tangent to our budget line. So we can't go beyond this budget line, right? It's like a dam. We can't go through the line, right? So our optimal point here, point O, our original optimal solution, O, it's going to be a indifference curve that is just tangent. This curve touches this budget line once, it intersects it once at this dot here. And leisure is 4.1 and consumer goods are 390.9, right? So in terms of C, the budget constraint is what? Well, we got to plug in our wage times our time, right? So our wage times time is 784, right? That's that value, right? The intercept. And then we got our wage of 980. So our budget line is C equals 784 minus 9.88 L. So let me make this my budget line. So that's my intercept, right? 784. And then I got to subtract off 9.8 times L. Whoop, I'm going to change this to wage, right? Let's see what our graph looks like for consumption. It should look like it does in, I'm going to change it to black. Okay. So I got to stretch the y-axis, the c-axis. I'm going to make this, I don't know, 1,000. Okay. So there is our budget constraint. Now, leisure lives between 0 and 80, right? So leisure is going to be less than or equal to 80, but greater than or equal to 0, right? Okay, so leisure can go from 0 to 80. It can't be beyond 80 because that's all she has available for work and leisure, right? And then leisure obviously can't be negative, right? Let's tie the rest of that. Okay, so that's our budget constraint, right? Now, at the optimal level of consumption, the worker chooses 40.1 hours, right? 40.1 hours of leisure. So given that was given to us, right? So if our leisure is 40.1, that means our consumption is 391.02. We'll just use this value here at 390.9. So consumer goods and services are 390.9. Hours of work. So H equal T minus L. T is 80. L is 40.1. Hours work is 39.9, right? And the utility is 398. 398. The worker's marginal rate of substitution so the marginal rate of substitution, if you remember, is the slope of the indifference curve. And as you move up the indifference curve, the curve gets steeper, right? It gets really steep up here, right? Why that is because leisure's scarce, consumer goods are super abundant. So if this person wants one more of a scarce good called leisure, that person's willing to give up a lot of leisure for a little. So this person's willing to give up a lot of consumption for a little increase in leisure, right? Down here, the opposite is true. Consumption is scarce and leisure is super abundant. So this person is willing to give up very little consumer goods to get a little more leisure, right? Because leisure is not scarce. Leisure is super abundant, right? But at this optimal point, the slope of the indifference curve equals the slope of the budget line, right? If you focus in right here and ignore everything outside of this oval line drawing, then they look like a line on top of a line with the same slope. So the slope of the marginal rate of substitution is a negative 9.8, right? And that implies that the worker is willing to give up $9.8 in consumer goods to get an additional hour of leisure. So here, if the person wants one more hour of leisure, right? They want one more hour of leisure, they're going to give up basically their hourly wage of 9.8, right? And that movement is along this indifference curve. So utility is being held constant at 398. So they're willing to give up $9.8 in consumer goods, their wage, because they're taking off an hour from work. So they're losing out on the opportunity of making that 9.8. That extra hour of leisure is costing them 9.8 units of $9.8, right? And their utility is being held constant at 398 when they do that. Okay, so as you move up or as you move down along the indifference curve, the slope of the line gets closer to 0, but the utility is being held constant at 398. So utility remains constant, and the marginal rate of substitution gets closer to 0, right? Now, after the government imposes a payroll tax of 40%, what's going to happen to the budget line? So to do that, we're going to delete this and delete that and get back to our budget line, right? So the government's going to impose a tax of 40%. What does that mean? Well, if the wage is $9.80 and you tax it 40%, which is 0.40, the person ends up paying $3.92 of tax on that $9.80 in earnings, right? Now I got to subtract that $3.92. I got to subtract that from the 980, right? So 9.8 minus the amount of tax leaves the person with $5.88 per hour. So this would be the wage, the net wage, the wage net of taxes, right? Now there's an easier way to do this. We can do it all in one step. We can multiply 9.8, the original wage, times 1 minus the tax rate, right? 9.8 times 1 minus the tax rate is 588, right? So we're gonna copy this part up here to here, right? So what happens to our budget line? Now, when I copied that in, the budget line changed, right? So let's do this. I'm going to change this back to 0. Suppose the tax rate is 0%. The budget line is steeper, right? The budget line is steeper, right? If I change this back to 40% tax, what happens? The budget line rotated counterclockwise at this point down here, right? It was up here, right? It was up here. Now it's down here. So it rotated counterclockwise via this point, right? So the budget line does what? It flattens. It got flatter, right? When there was no tax, right? When there was no tax, this point was higher, this point was stationary, right? With the tax, this point is stationary, this point slid down. So the budget line flattens, right? And that's what you see here, right? The budget line flattens. It rotates. The budget line rotates counterclockwise via that point right there, right? Okay, the new optimal solution is 44.3 hours of leisure and $209.80 in consumer goods, right? This is the new budget line. 470.4 comes from that value, right? And then this is our new wage. That's our tax adjusted wage, right? That's our tax adjusted wage. At the new optimal solution, point F, the worker chooses how much leisure? 44.3, right? And so if the person is choosing leisure equal to 44.3, right? 44.3 hours of work is equal to the time constraint minus the leisure hours demanded. So her hours work is now 35.7. So the person works 35.7 hours, right? The consumer goods are 40, sorry. The person at this point F, the final optimal solution, the consumption level is 209.8, right? $209.8. Okay. What is the utility? Well, this indifference curve, this red indifference curve, the new indifference curve that is tangent to the new budget line, it's closer to the origin than the previous indifference curve. So that represents a decrease in utility to 353. Oh, 353, right? 353. The worker's marginal rate of substitution at this point. So at this point F, the indifference curve, right? The indifference curve and the budget line have the same slope, right? Here they don't. At this level of leisure, they don't have the same slope. At this level of leisure, they don't have the same slope. This is really steep and this is really flat. But at this point, they both have the same slope. And that slope is the tax adjusted wage, right? So the marginal rate of substitution at this point is a negative 5.88, right? The tax adjusted wage, right? So here, right, at this point, in order to get one more hour of leisure, the person has to give up $5.88 in consumer goods, which equals the wage, right? And we're holding utility constant when we do that substitution, right? We're moving along the indifference curve here, right? And the utility is 353. We're holding it constant at 353. Okay. Now, imposing a payroll tax decreases the effective wage rate to the worker is paid by. It reduces imposing a payroll tax decreases the effective wage rate the worker is paid by what amount? So the previous wage was what? 9.8. So that was the first wage. The wage net of the taxes is 5.88. So wages fall by $3.92 per hour. Which leads to a decrease in hours of labor the worker supplies. So the worker initially supplied 39.9 hours, right? So workers initially supplied 39.9 hours. Now the worker supplies 35.7 hours of work, right? So hours of work fell by 4.2, right? Hours of work fell by 4.2. Now the slope of the worker's labor supply curve is the ratio of those two, right? So this is the change in the wage, and that's the change in the hours of work supplied. So what I'm going to do here is I'm going to do divided by, then I'm going to copy this, that change in the hours worked. So I got the change in the hourly wage over the change in the hours of labor supplied. And we see the slope of the supply curve, of this worker's supply curve, is 0.933. Whoops, I put it in the wrong spot. Oh, man. Yeah, I copied and pasted in the wrong square. This should be 4.2. Okay, so yeah, when I copied this in by mistake, the 0.93 into here, I changed it back to 4.2, right? So there's a decrease in hours of labor supplied by the worker, and that'd be 4.2 because the worker was supplying 39.9 and now is supplying 35.7. So this is a decrease of 4.2, right? So the labor supply curve looks like this. We got the wage equal to a slope of 0.93 times hours worked plus some intercept. And we'll come up with that later, right? And the labor supply curve is upward sloping, right? We'll come up with that later. Okay, the decline in the wage rate has multiple effects. First, it results in what? The decline in the wage rate has multiple effects. It first results in a consumption rising, no. Income rising, no. Hours worked rising, no. Leisure decreasing, right? Leisure decreased. Leisure decreased from 44.3 to 40.1. Hours worked rising. Hours worked rising. Yep, that's true. Okay, I went through and edited this list because I had 3 situations that were true. Utility decreasing, hours worked previously was increasing, and leisure was decreasing. So I had to change these 2 because the correct answer is utilities decreasing, right? Utility decreased from black to red, from 398 to 353. Okay. Now, and pressing enter decomposes the substitution income effects. We have what are essentially 3 optimal solutions. The original optimal solution, we observe that with data. We observe how many hours the person works at the untaxed wage rate. We observe what the individual does with respect to work, after the tax effectively lowers their wage. This optimal solution here is not observed. This point here is in the head, is unobservable. This is in the head of the worker. We do not observe point H, right? But we can use theory to imagine what it looks like, right? So from O to H, the black line is parallel to the green line, right? So what we're doing is we're holding the wage rate constant from black to green. So we have this parallel shift. So this parallel shift is like in the previous problem where we had a toll that extracted a fixed amount of money from the worker each week, right? And it caused a parallel shift in their budget line. And I mentioned that that was an income effect, right? So a parallel shift from black to green is like the person's monthly allowance was removed, right? So this is an income effect from O to H. And then from H to F, we're moving along the red indifference curve from H to F. And what's changing is the slope. The utility is being held constant along this red curve, right? Utility is being held constant here, but the slope is changing, right? So here, the slope is the wage after taxes, 5.88. Here, the wage is here the wage is 9.8 because it's the same as it was initially, right? And this point, the indifference curve is steeper than the steepness at this point on the indifference curve, right? So we're basically what we're doing here is we're keeping utility constant as we change the slope of the indifference curve, which means as the wage rate declines, the slope of this indifference curve shrinks, right? We're holding our utility constant. So from H to F is our substitution effect. From O to H is our income effect, right? So the income effect is modeled by points O to H, just like I said. From O to H, the maximum income the worker could earn at 80 hours work, right? So the maximum amount of income the worker could earn if they worked 80 hours a week and had 0 hours a week of leisure, right? So if they work 80 hours a week, right, they'd have 0 hours of leisure, and the person's income would be 784, right? So moving from O to H is an income effect where the change in the income is the difference between this 784 and this is 607.9. So right here, I have the 784 minus the 607.9. And so moving from O to H is like, it feels like your income fell $176.1. Feels like your income fell $176.1. So your income was 784. If you work, again, 80 hours a week and have 0 hours leisure, 784 to 607.9. Okay. Leisure declined from what? Leisure declined from 0.0, 40.1, right? To the leisure at point H, 28.6. And the hours of labor supplied increased from what? So let's go over here. So leisure was 40.1, right? Leisure was 40.1, right? So hours of work were 39.9. And then at point H, right, leisure is 28.6. Again, we don't observe this. This all happens in the head of the worker. So hours worked increases to 51.4. And that's the income effect, right? From points O to H. So hours worked were about 40, 39.9. They increased to 51.4, right? 51. Hours worked here is 51.4, right? So you had this huge increase in hours worked. That's all the income effect. Now the substitution effect, let me go ahead and hit enter here. Now the substitution effect is from H to F because what we're now allowing to happen is the slope of the indifference curve, again, is allowed to be changed, right? Along this indifference curve. Here, the slope is steep. Here, the slope is flatter. So here, the absolute value of the slope is 588, the value of the tax-adjusted wage. Here, the slope is 980. It's the same as the slope here, right? Because the black line and the green line are parallel. So here, the wage is effectively 980. Here, the wage is effectively 588, right? So what happens if we hold utility constant? What happens to leisure, right? As the wage declines from 980 to 588. Now, remember, when the wage falls from 980 to 588, that means leisure's become cheaper. And when a good becomes cheaper, you buy more of it. And leisure increases from 28.6 to 44.3. So leisure increases from 28.6 at point H to 44.3 at F. 44.3. A point F, right? 44.3. The substitution effect model is modeled by the slide along the U equal what indifference curve, where we're holding U, utility constant, at 353 along this indifference curve. So we're holding it constant at 353, right? So utility's been held constant at 353. Hours of labor supplied decreased from 51.4. Remember, at point H, this was the leisure hours that we would observe if we could observe this point. Again, H is hypothetical, it's in the worker's head. And so if we could observe that hours of leisure that they desired after the income effect takes place, then we would observe 51.4 hours of labor, right? So hours of labor goes from 51.4, right, to 44.3 subtracted from 80, right? So now hours of work are 35.7. 35.7. So here the worker's labor supply curve will slope upward, right? It slopes upward because right here, the slope is positive, right? So the labor supply curve will slope upward since the income effect, right? The income effect dominates. So the substitution effect is from point O to point H. So moving from here to there is smaller than moving from H to F. So the income effect is from the green to the red. The income effect is from the black to the green. So this effect is smaller than this effect, right? So when the income effect dominates when the substitution effect right here, green to red, when green to red, the substitution effect dominates the income effect, black to green, what happens is leisure goes up, right? Leisure goes up in net, right? From O to F, leisure goes up. Okay, let me. Okay, so like I said, leisure in total, in net, from what we observe initially to what we actually observe in final, leisure increased, right? So leisure increased. When leisure increases, hours of work decrease on net from 0 to F, right? From O to F, point O to F. Now, hours work went down. At the same time, the wage rate went from large 9.8 down here to 5.88. So we had a decrease in wage and we had a decrease in the effective wage. So we have a decrease in the hours worked and a decrease in the net wage, right? The net wage. So both those effects are negative. So the ratio of those two is positive. So the slope of the labor supply curve is positive, as we said here, right? And it slopes upward because the income effect is dominated by the substitution effect. Now, if the worker's supply curve, the worker's labor supply curve will be downward sloping when the income effect dominates the substitution effect, right? So if the income effect dominates the substitution effect, then the shift from black to green will be bigger than green to red, right? And so we'll get a downward sloping labor supply curve, right? And that usually happens when wages are really high, like doctors, for example. When you get paid extremely high levels, the income effect is going to dominate the substitution effect. But at lower wage rates for poorer people, for middle income people, the income effect is going to be dominated by the substitution effect. Okay. And we can actually figure out what the labor supply curve is, right? By using the original point. At point O, hours of labor supplied was 39.9. Right. And the wage initially was 9.8. Right. So when the wage was 9.8, right? When the wage was 9.8, we'll go back to the original. When the wage was 9.8, leisure was 44.3, and hours worked were 35.7, right? Wait a minute. Sorry. Originally, leisure was 40.1, right? 40.1. So hours worked were 39.9. So when the wage was 980 and leisure was 40.1, so when the wage was 980 and leisure is 40.1, hours worked were 39.9, right? So I can actually solve this for W. I can solve this for W, and then I can come up with the labor supply equation, right? So what I'm going to do here is I'm going to distribute 9.3 to the H and to this, right? And then I'm going to add 9.8 to both sides. So I can do this arithmetic in Desmos. The intercept is 46.907. So the intercept is negative. The slope is positive. And so if I reload this, I can actually graph the labor supply curve that we just derived. W equal 0.93 times H minus 46.907. So it's upward sloping, right? Is that right? Let's try this. If H is 39.9, oh, I got a mistake in my algebra. I got a mistake in my algebra there. I got to add 9.8 to both sides, right? I got to add 9.8 to both sides. So let me plug this into Desmos. My intercept is negative 27.307. Right. Now, I'll change this up here. I'll change this up here to 27.307, right? So now that's my labor supply curve, right? Right. And if hours worked is 39.9, then the wage was 9.8, right? When leisure is 44.3 after the wage increase, 44.3, hours worked were 35.7. So if I change this to 35.7, I get a wage of 5.88, right? Essentially. So that's my labor supply curve, and it's upward sloping. Okay.